to Zachary's zone. Okay, so let's go ahead and jump into the lesson. What are we learning today? Apply the math process standards to use proportional and non-proportional relationships to develop foundational concepts of functions. We are expected to identify functions using sets of ordered pairs, tables, mappings, and graphs. So from that standard, we see we are to use the process standards to develop students' understanding of functions. At this grade level, we do not have to worry about function notation, but we do have to make sure students understand the definition of a function, which is for every x, there is only one y. In other words, if the x coordinate has two different y coordinates, it is not a function. So as I have said before and often, if we are not reading the process standards, then we are missing a critical piece to helping students understand mathematical concepts. They are the how and with what as we work through our intended learning. When students are explaining proportional and non-proportional relationships, they need to be able to make connections to everyday life, use tools like paper and pencil, technology. They should be able to organize and record their mathematical ideas. Always, our vocabulary is important there. So, like I've said before, if you don't have your vocabulary word wall up, let's get it up. Okay, we should always be making reference to it and encouraging students to use precise mathematical language. So, what are we learning today? I think that's the first thing we have to always ask ourselves. We want to make sure that our learning objective is in student-friendly language. Let's go ahead and pull out the important vocabulary and stamp that with students. So, our learning outcome for today is I can determine whether a relationship is a function and whether it's proportional. Is it possible for a 2D shape to represent a function when plotted on a graph? Will that shape be proportional or non-proportional? Think about that. Okay, so notice I put these pause and ponder questions in here. Okay, you may want to use those to hook students. Okay, that's a great way to see if they have processed the vocabulary, if they understood the learning from the day before. Okay, if they're able to make those connections as you go into the next lesson. As we think about this, we want to make sure that students understand the multiple representations that are embedded within this lesson. What do my students need to know? Okay, we have a quick list here. Again, if you want to use this as a quick way to generate a no-show chart, or you can use this as a checklist to see if you have taught everything and made sure that students understood all of the different pieces, feel free to do so. So what do my students need to know? Okay, they need to know input and output, the definition of a function, X and Y coordinates as ordered pairs represented in a table, graph, or mapping. They need to know what the vertical line test is. Okay, we also need to look at proportional versus non-proportional. And then we want to define our origin, which is at 0, 0. As we move into what our students need to be able to show on their papers or their screens, we have our rule draw right protocol that we're sticking with. Okay, so for the rule is for a function, for every x, there is only one y. Okay, so when we think about our vertical test, when I was teaching, I would tell my students, once you graph your line, take your pencil. Okay, and if you're able to just take your pencil and move your pencil along the line vertically, does your pencil hit more than one point? Okay, if the answer is that it only hits one point, then it is a function. But if that pencil is hitting more than one point, it's not passing the vertical line test, which means that it is not a function. Okay, so they're going to draw. In their draw box, they're going to map their ordered pairs, identify the y-intercept, and then of course we always want to be able to write a sentence to describe what we're doing. So in this case, if the set of ordered pairs is a function, and if it is proportional. Okay, so as we think about this, I have a sample hook that you can use with your students to launch your lesson. So again, we're talking about functions and whether a situation is proportional. All right. So when you go to a soda vending machine and you put your $2.50 in. Notice I said $2.50 because we know to purchase a soda these days is expensive. Okay, it used to be where it was much cheaper than that. But anyway, all right, you put your $2.50 in to purchase a soda. What do you expect to receive? Okay, if I put in X, $2.50, I should only receive one soda. Why? That is a function. Every time I put in X, $2.50, I'm going to get back Y, one soda. Have you ever gone to the soda machine and put in $2.50 and it's your lucky day and you get two sodas? Okay. So for in a situation like that, the soda machine is not functioning properly. It malfunctioned. It is not a function because you put in $2.50 X and you got a Coke and a Sprite. Okay. You got two Y's for the same X. Okay, so if you want to use that as an example, maybe your students can generate others, but these are just some of the things that we can kind of use to make it make sense for students. So here's a sample anchor chart that I made. Feel free to use this to create your own, or you can visit my site to download a copy. For this lesson, to increase engagement, you may consider for the guided practice making some red and green cards, similar to what I am holding up on the anchor chart for each student. As you work through problems together, have students hold up their cards once they get an answer. So often we ask questions and students just popcorn out answers, or we cold call students and the same students answer each time. As a principal, when I would observe classrooms, I would watch for that very closely because my thing was, well, if that student's always answering, how do you know the other students know? So consider making some green and red cards for your students. You may also want to consider whiteboards. Whiteboards are a very useful tool where you can ask students to record their answers and hold it up. This will keep students from looking to see what their neighbor has and mimicking their answer. Sometimes sharing answers is okay when we are encouraging peer-to-peer learning, but we also can use this as a tool for accountability. Now we are going to look at a couple of questions. So we see here on the screen, we have a table. For this first question, it says, is this a function? Why or why not? So just as a caveat, as we're planning for instruction, we want to give our students a lot of practice on using these interchangeably because they will be asked to identify different representations. Okay, so we want them to kind of get used to representing them all. When we're looking at this question, is this a function? Why or why not? In my rule box, I want us to remember the definition that we used for a function, which was for every x, there is one y. Okay, meaning that for every x coordinate, there is exactly one y coordinate. Okay, so immediately, if I were to start with my ordered pairs, if I wanted to first write this as a set of ordered pairs, I would have 1, 2. So I'm just looking at every row of my table. 2, 4, 3, 6, and 2, 5 is my set of ordered pairs. What do we notice here? The first thing that jumps out at us is that we have the x coordinate 2 paired with two different values. Okay, the x coordinate has a y coordinate of 4 and it has a y coordinate of 5. That means that this is not a function because it does not fit the rule of for every x there is one y. Okay, in our drawing box, if we had students map that, we would see that if they were to draw their x values 1, 2, and 3, because those are the only x coordinates that we have, 1, 2, and 3. And then for our y coordinates, we have 2, 4, 5, and 6. When we map that, we see that 1 goes to 2, 2 goes to 4, 3 goes to 6, and 2 goes to 5. So see how we have two lines coming off of our x coordinate of 2? Okay, so this is not a function. So when I look at my question here, it says, is this a function, why or why not? In my right box, I'm going to answer the question. I'm going to say this table is not a function. Why is this table not a function? Because there are two values for the x coordinate 2. And then if you want them to write it or circle it, you can tell them how you want them to um, identify that for you. So for this next question, we see we have a graph. And the question says, is this a function? Why or why not? So the first thing I want to do is I want to identify my rule, which says for every x, there is only one y. That's the rule. Okay. So then when I go to my graph, you can decide as the teacher if you want them, how many points you want them to identify. Okay. But I would say always identify more than two. Okay, just as a rule of thumb. So if you want them to identify 4 points on the line, 5 points on the line, 3 points on the line, let's just go more than two. Okay, so if I were to identify points on this line, I see I have a point here, a point here, here, and here. Okay, so the first thing I want to do is represent this as a set of ordered pairs. Okay, what are these points on the line? So I see I have -2.5, -2.5. I have 0, 0. I have +2.5. And if you want them to represent with decimals or fractions, that's your call. And I have 5, 5. So just by looking at my set of ordered pairs, I see that I do not have any y's sharing an x coordinate. But I'm going to check it. Okay, so now in my draw box, I'm going to represent these ordered pairs in a table. So if I were to represent my ordered pairs in a table, in my x column, I would have -2.5, 0, 2.5, and 5. And in my y column, I would also have negative 2.5, 0, 2.5, and 5. So we see that so far it checks out as a function. Students can also do a mapping of that. So we're teaching them all of the representations because we want them to be able to recognize them, but we also want them to be able to choose the one that best fits their needs. Okay, so if I do a mapping of this, I have negative 2.5, 0, 2.5, and 5. I have the same thing for my y coordinates. And when I map that, I see that there is no sharing. There is a one-to-one correspondence. For every x, there is exactly one y. So going back to my question, what would I write in my right box? I would answer the questions. Is this a function? Yes. This graph represents a function, y equals x, because for every x, there is one y. And we're done. This time we have a set of ordered pairs. Is this a function? Why or why not? Okay, so we're given a set of ordered pairs. We have some options for checking if this is a function or not. Okay, so we can make a table, we can do a mapping, we can also graph this in our calculators or on Desmos. So the first thing I'm going to do is I'm going to start with my rule box, which says for every x, there is only one y. Alrighty. And then I'm going to go to my draw box and make a table of these values. So for my table, I have x on the left, y on the right. I'm going to represent my x coordinates in the x column. So I have -4, -2, 0, 2, and 4. And for my y values, I have -3, -4, -5, -6, and -7. In looking at that, so far, it checks out as a function. I do not see a situation where my x coordinates are being shared by my y's. Okay, we can also do a mapping where we have x and y. So we have -4, -2, 0, 2, 4, and then we have -3, -4, -5, -6, and -7. And again, we have a one-to-one correspondence. Now, here's what I will say. Couple of things to look for, watch out for. The direction of the arrows. If we were to write a sentence about this, we would say this set of ordered pairs is a function. Why? Because for every x, there is one y. And that's it. Now I want to go back to the question that I posed at the very beginning of this lesson. And I asked the question as part of our ponder, our pause and ponder. And my question was, is it possible for a 2D shape to represent a function when it is plotted on a graph? And here we are. Will that shape be proportional or non-proportional? Okay, so let's look at it. Let's follow the same rules. Our rule box, it says for every X, there is one Y. That's the rule. We see our ordered pairs are labeled here for us. We have 2, 5. We have 6, 10. And we have 2, 12. Okay, so automatically we see that we have the X coordinate being shared by the Y coordinates 5 and 12. So immediately we see that this is not a function. Okay, this is not a function. When we make our table, we have 2, 6, and 2. And in our Y column, we have 5, 10, and 12. So we see we have the 2 is repeated. So it's not a function. If we mapped it, we would have 2 and 6. And over here, we would have 5, 10, and 12. And we would see that this 2 would go to the 5, 6 would go to the 10, and the 2 would go to the 12. So we have 2 lines coming off of our 2, indicating that the 2 is being shared by the Y coordinates. And so in our right box, we would say this shape does not represent a function because for the X coordinate, 2, there are 2 Y values or 2 Y coordinates. The other thing is that we think about the vertical line test. Okay, that's another way to describe whether or not this is a function. So when like I said, if you take your pencil and you just kind of lay your pencil across the graph, so in this case, I'm going to draw lines to represent that. We see that if this red line represents my pencil, when I draw vertical lines, for every line I draw, I'm hitting that triangle in 2 points. Okay, it does not pass the vertical line test. Okay, so therefore, it is not a function. This first question, we answered the question if it was a function or not. My next question is this proportional? Is this proportional? Okay, we do not see a situation where this, well, we know this isn't a line. and it's not crossing through 0, 0. So this is not proportional. For this question, what will we say here? Yes, it is proportional because it's passing through 0, 0. So this is proportional. For this one here, will we say, is this proportional or non-proportional? It is non-proportional because here's the y-intercept. The y-intercept is passing through at -5. It's not passing through 0, 0. So this is non-proportional. This is non-proportional because it does not pass through 0, 0. Not to be confused with our transformations that occur about the origin. Okay, very different. Alrighty, so to recap our lesson for today, we looked at whether or not relationships were functions and if they were proportional or not. And we did this by looking at our set of ordered pairs and determining whether or not there was a one-to-one correspondence in terms of it being a function. We did this by representing in tables. We looked at how it was represented on graphs. And we also looked at some situations where there were mappings of ordered pairs. So the key here that we want to stamp for students is that for every x, there is exactly one y. Okay, and if there is ever a situation where the x coordinate is paired with two different y coordinates, then it is not a function. Okay, and when we're talking about proportional and non-proportional, proportional is if it passes through the origin at 0, 0. Non-proportional is if it passes through the y-axis at a different point. Alrighty, so that's all I have for you today from Zachary Zone. Until the next time, thank you. See you later. I want to share with you my website. I have started my own website for professional learning for teachers. It is www.grayjaysimagination.com. It is in honor of my son. But as you can see here, I am Sherry, your instructional leader. I do bring experience as a principal, an instructional math coach. My degree is in math education. I'm currently working in research in math education at the university level. But at the end of the day, from the bottom of my heart, I am still a teacher. I love teaching. I love working with students. I love working with teachers. I just want to say thank you for what you are doing in the classrooms. You make the difference. All right. Have a good day. Talk to you later from Zachary Zone.